The following trend research presentation, we're going to explain our trend, which is wood for tall buildings, and particularly it's going to be mass timber construction. So to introduce you a little bit about the topic, we explain the major role that it has in the economy, the creation of roles and job in the construction world, and how it's accountable for residential, commercial, civil, and transportation infrastructure in the country. So the importance of innovation in an industry such as construction, which is very conservative and very traditional, is that wood for tall buildings tries to make things simpler, makes things more profitable, and also more sustainable, which is the ultimate goal of this technique. Timber has been used traditionally in the construction industry, especially in the Anglosphere, is that it was mainly used for residential housing. It started in the Great Britain, and because Great Britain was a fairly small island, the sourcing of timber was very limited. Some of the problems that they made is that they had to come up with new solutions, such as concrete structures, things that were not renewable, but that were easy to source anywhere in the world. Another thing that happened after that was the implementation of steel structures, which allowed for skyscrapers and tall buildings with very huge spans. But of course, it developed a lot of toxicity and a lot of pollution. Recent trends point to mass timber as the predominant construction technique in the world, and the reason has to do with the previous two. So to make concrete structures, you need a lot of material that ends up going into waste. Mass timber, the beauty of it is not only the source of the material, but also the fact that you don't need to use a lot of material that ends up going into waste. What you use is what you end up having in the building. So there are less steps to make it happen, and it also makes it more affordable to build. So the latest trend that allowed mass timber to happen was the implementation of cross-laminated timber, which is shortened as CLT. And what this makes possible is that you can have long spans, and tall building allows for a long span. CLT beams and columns, as you can see, most architects and designers like to leave them exposed as well for the beauty of wood as an architectural finish. And you can see most of its joinery, it's made out of steel plates and bolts, but the overall beams and columns are made out of cross-laminated timber.
Some projects in timber frame. The first project is in Olympus Lost Place from Durrant College. That project is in this moment is construction. Here you can see a picture about the job site management. You are making the one bridge composed by timber frame, of course. Other project that is complete is the Art Gallery of Ontario. The most important in this project is that beam, that pier you can see. The shape, that shape you can only make it in factories, no in job sites. That's impossible. That is the difference with the concrete construction and timber frame construction.
The strength of mass timbers are made out of renewable material, being manufactured in factories prior to getting to the job site, having high precision joinery from the factory, reducing it for the skilled labor, easy for installation when reaching the job site, quick assembly when compared to steel or concrete, no need used for work of extra disposable material, no need to cover with sprays or drywall. Components are final finish. Components are lightweight and have tolerance to vibration and seismic movement. Easy to estimate amounts with minimum waste, cost effective, and less waste on disposable materials overall. And the business of mass timber construction are required manufacturing infrastructure, distribution of lumber may be restricted to certain regions, shipping costs might increase price of products, not able to quickly scale with the material sourcing, requiring local regulation and standards to the quality of lumber being used, and requires supervision of where the wood is coming from to guarantee the reforestation safety.
I will talk about the opportunities. Improve the global infrastructure of manufacturing of easy for scalable, source from certified forests only, and reinforce law and construction permits that implement these construction materials. Strengthen local code regulation for restriction on hazards like seismic activity and fire. Specific risks involved on the infrastructure integrity when passing a certain high-rise threshold, and much more research to be done on making construction process more efficient, both on the factory and the site. About the threats, fire tolerance need to be tested, and seismic activity tolerance, resistant and rigidity and strong wind, regulation, and how many stories can be built permit and geographic location. That is important. And reforestation, tenure frame, and permit.
So a few things to talk about. Firstly, we're going to talk about tall wood buildings on weak soil. All right. So we're talking about timber and using timber. So why is it best? Why does wood work better for weak soils? First of all, using wood or timber for constructing buildings, it allows you to build taller buildings on soil that cannot hold heavier materials. So that's why we are talking about this now. We have foundation and superstructure. Basically, timber is less heavier as compared to concrete or steel. All right. It provides a safer environment for workers and neighbors. Less noise as well. So basically, working with timber, or for instance, downtown, working with metal, there's a lot of clanging, so neighbors around might complain about the noise, etc. And heavier materials means more risks for workers. So yeah, it's a safer environment for workers and neighbors. The structural systems for tall wood and hybrid buildings. So basically, we're talking about structural elements of wood construction or timber construction. So how does it hold together? More explicitly in seismic regions. All right, so we have bracings. There are different bracings, as you can see here in this example. Brace frames gives timber the ability to resist lateral loads. All right, as you come down to the point, you see load carrying capacity. It has a great load carrying capacity while being best, as we just discussed earlier in the previous slide. And the structural system for tall wood hybrid buildings also helps reduce the lateral movement in seismic regions.
Efficiency and environmental impact on timber on tall buildings. So the first point is key structural material in large-scale construction. So timber plays a crucial role in large-scale construction, alongside with materials such as steel and reinforced concrete. And its environmental advantages are maximized when strategically used for structural efficiency. So the next point is emphasis on being cross-laminated as opposed to parallel grain. Timber strength parallel to the grain is comparable to reinforced concrete, and it lacks in compression strength against modern high-strength concrete.
So, taller wood buildings and fire safety, existing evidence about large wood construction. So, these are two different fire scenarios. This is CLT and this one is steel structure. So, basically, this one, steel structure, it melts down due to fire because it has less density, unlike the CLT. For the CLT, during fire, it just burnt the surface, but the structure of it didn't break down. So there are two main reasons for that. The first one is the wood density, and the second one is the fire additives. and it has to be present to the CLT to make it stronger. And those additives are tannin, phosphoric, and boric acid, and it minimizes the possibility of collapse up to 30%. And the fire could go over for like 2 hours without breaking down the structure.
Another research that we made is cross-laminated timber in tall buildings. COT panels are commonly used for shear walls. What allows us to use them there is high-strength tap-in screws. The reason why we need them is because in high-rise building, we can't have any wood-to-wood connections because of the fire resistance. It also allows us to use it in floors and roofs, and we also have two span capabilities similar to concrete slabs. It means that the slab is longer than the lumber slab that we usually use.
So now to conclude, mass timber structure present in mid-rise and high-rise buildings is an innovation to the industry because of many of the reasons we have explained, such as sustainability, environmentally suitable designs, its profitability for the construction industry business, and also the fact that you can minimize time frames in a significant span and build overall better buildings that take care of the environment, take care of the budget, and help shape the city in a better way.